Okay, so I'm going to go to, so far for this course, you've studied linear equations or how to graph them. This is algebra 1, and then we did absolute value, and this is algebra 2. So there you have domain and range and all the information that you need to know about this function. Then the last function I taught you how to graph is the quadratic function, which is a parabola. Okay, so today I'm going to add one more function, okay, to this. So I'm going to do the last function on the bottom of the first page. So to do this function, I'm going to give you a table of values. Okay, so this is called the parent function of the square roots. When you see me write PF, that's what it stands for, parent function. Okay, so the values of x that we can use for the square root function. No, don't forget, we can't have negative numbers inside of the square root because those numbers are what type of numbers? Imaginary, right? They're imaginary, so don't forget that. That's why we can't use negative numbers. But we can use 0, 1, 4, 9. And notice that I'm doing something convenient here. I'm only using perfect squares. Because when I take the square root of 0, that's 0. Square root of 1 is 1. The square root of 4 is 2, right? So notice, do not forget that I said this in class. These are for directions. They're not coordinates, okay? So what this means is from the origin, which is 0, 0, if I go right 1, up 1. If I go right 4, 1, 2, 3, 4, up 1, 2. So then connect the points, and this is what the graph looks like, okay? And something that I'm going to mention briefly is that this function and this function, there's a relationship between them. And that is that they're inverses, okay? But I'll come back to that in another lesson. All right, so domain for this function. Notice that for domain, it goes from 0 to infinity. So then we say in set notation, okay, so set notation, x such that x is greater than or equal to 0 because we go from 0 from here to the right. So all the values greater than or equal to 0. So this is set and this is interval. So I'm coming back to this even though I've covered that already, but I know some of you still struggle with this. So it goes from 0 and that's included. So we use a bracket, but then it goes to infinity and infinity gets a parentheses, okay? So that's the domain of this one. The range also from 0 and goes up to infinity. So y such that y is greater than or equal to 0 because from 0 this graph goes up, not down. Then y-intercept and x-intercept right at the origin both 0, 0, and the y-intercept is also 0, 0. Asymptotes, this one has none. Okay, so you won't see functions that have asymptotes until later on when we study exponential, logarithmic, and rational functions. So those are the only three that will have asymptotes. So I'm going to move this away, but I'll be referring to this table today for the parent function of the square root. Okay, so let's go to this paper now. So on numbers 1 through 4, I need to state the domain and the range only. Okay, that's all I need to do. But I'm also going to say the transformations because those are easy to do. So I am going to copy the parent function. So PF, the table. Okay, so parent function is y equals the square root of x. So then the table that I gave you on the pink paper, you have x values and y values. So I'm going to copy this table here just one time, and then we'll be using it on several examples. 0, 1, 4. 0, 1, and 2. Okay, before I continue, any questions about these values? You understand how we got them, right? Yes? All right. So then I see a minus 5. So notice, this is just x. There is a minus 5 with it, so that means this graph, that minus 5 is outside of the radical. So then the graph is going to go down. So this is the transformation, down 5 units. Meaning, instead of going from the origin, like this one, we need to move that point down 5 units, okay? So then I'm going to move that point down 5 units. 1, 2, 3, 4, and 5. So this is that point. since there's nothing in front of the square root, then I don't have to multiply or divide or do anything. So I just follow this table here. So if I go right 1, up 1. If I go right 1, 2, 3, 4, up 1, 2. And there are the 3 points that I need to be able to sketch this graph. And again, don't forget, this is not a line. This is a curve. Okay, so it looks like this. So notice that transformations do affect domain and range. In this case, domain still goes from 0, so domain did not get affected. So let me state domain in set an interval. So this is x such that x is greater than or equal to 0. And in interval notation, 0 is included because that value is on the graph, but then it goes to infinity as it goes to the right. Okay, so there is the domain for this graph. Questions? No questions? All right, the range then. The range, this instead of going from 0, now it's going from -5. So then this is y, such that y is greater than or equal to -5, because from -5, the graph points up, not down. Okay, then that's set notation interval, bracket, -5, then it goes to infinity. So there we have domain and range for the first example. So let's go to example number 2. So notice number 2 has a +2 inside of the radical and a -4 outside. Don't forget, whatever is inside a parenthesis or a radical, that means left and right. If it's plus, it's counterintuitive. Okay, this means left 2. So the +2 means the origin of the graph goes to the left 2 units, and then that -4 means it goes down 4. So I'm going to do that first. So from the origin, go left 1, 2, 3. Go left 1, 2, then down 1, 2, 3, and 4. So now this graph, which is like this one, will be starting from this point now. So if I go right 1 from this point up 1, if I go right 1, 2, 3, 4, up 1, 2, and then connect the points, and as you can see, it's the same graph. Okay. So for this one, the domain and the range get affected because this went to the left 2. So when we state the domain, we take that into account. So x such that x is now, instead of greater than 0, it's greater than -2. Greater than or equal to -2. So this is in set notation. In interval, bracket, -2, and then it goes to infinity as it goes to the right. The range goes from -4. So this gives away the range, that -4. The range is y such that y is greater than or equal to -4. And from there it goes up to infinity. So then in interval, -4, comma, infinity. So there we have domain and range for number 2. Example number 3. Now notice there's a negative in front of the radical. This, whatever is outside, affects the y values. So I'm going to copy the parent function table that I gave you on the pink paper and also on top of this page. So xy, 0, 1, 4. This is 0, this is 1, and this is 2. Okay, so I might not need all of this space. Then what I'm going to do is I'm going to change the sign of the y values, because whatever is outside of the radical affects the y values. So then this will still be 0. This now becomes -1. This turns to -2. Then I'm going to go back and cross out the center column because I won't be using those directions. Okay, so we still go from the origin, which is this point. So that's the first point. But then if I go right 1, down 1 instead of up. If I go right 1, 2, 3, 4, down 1 and 2. So there we have again the 3 points that we need to be able to sketch that curve. Okay. So when it comes to domain still goes from 0 to the right. So domain did not get affected in comparison to the parent function. So I'm going to separate this here. Domain is x such that x is greater than or equal to, from 0 to the right. And in interval notation, bracket, 0 to infinity. Okay, so that's the range, the domain. Notice the range does get affected because it's, instead of going up, now it's going down. So it doesn't have a bottom, but it does have a top. Okay, so the range is y such that y is, now watch this, instead of greater than, this is going down, so we say less than or equal to 0. So that's set notation, interval. We don't write 0 first because this is going down, so that means always go from bottom to top. So negative infinity, but then it gets to 0, and that's where the graph stops. So now notice these two switch, again, because of what's implied by the graph. So I am going to, let's go to number 4 then. So this is the last one that I'm going to state domain and range for. So there is a 2 in front of the radical that affects the y values. So again, I'm going to do the parent function table. So this is x, y, 0, 1, 4, square root of 0, 0, square root of 1 is 1, square root of 4 is 2. But now we take this 2 into account. Okay, so I multiply the y values by 2. So then this is still 0, this is 2, and this is 4. Then I'm crossing out this column. Okay, so there is no up or down, no left or right. So that means we go from the origin. From here, if I go right 1, up 2. If I go right 4, I need to go up 4. And as you can see, that value of the value of 2 makes the graph grow faster. Okay, it grows faster than when you don't have a scale factor in front. So let's go back and do domain and range. Domain is the same as the parent function because we're going from 0. So x such that x is greater than or equal to 0, and in the interval 0 to infinity. Okay, the range is the same as the parent function. So the range is y such that y is greater than or equal to 0. So that's set notation. In interval, we say from 0, that's the bottom, and then it goes to infinity. So there is no top for this one. It just keeps going. So there's 4 examples on how to graph, how to do transformations. I didn't do transformation on this one, did I? So let me just go back and write the transformation for number 3. So the only transformation is it's got reflected or reflect over the x-axis. And this one has a vertical stretch. By 2. You multiply, or we multiply the y values by 2. So that's why it's vertical. Okay. All right. So that is all for 1 through 4. Let's go to 5, 6, 7, and 8. Okay. So let's start with number 5. For 5 through 8, I don't need to give domain and range. I need to state the x and y intercepts, but we will be able to see them on the graph as we sketch the graph. So first, notice the transformation. Plus 4 means the graph's going to go to the left 4. Okay, which means I can use this table again because there's nothing in front of the radical. So if I go left 1, 2, 3, 4, this is where we start. From there, if I go right 1, up 1. If I go right 1, 2, 3, 4, up 1, 2. And then connect the points, and this is the graph of that function. Okay, so x-intercept is right on the graph. You don't have to guess it, it's there. And it's where x is negative 4 and y is 0. That's this point here. Okay, the y-intercept has coordinates of, that's this point here. So this is where x is 0 and y is 2. So there we have the transformation, the graph, the x, and the y-intercept. Questions? I didn't say you can't talk. Okay, you can ask questions. I don't expect you to be quiet. Okay. Number 6, there is a negative in front of the radical, so that means we change the sign of the y values. That's all we're going to do. Okay, but let's do the transformation first. So this graph, that's minus 2 inside of the radical. It's going to take the graph to the right 2 units from the origin. And then that plus 1 is going to move the origin up 1 unit. So from the origin, go right 1, 2, and up 1. So this is where we start. Okay, so to get the other points, let's do the table of values for the parent and then apply the transformation by changing the sign of the y values like we did here. Okay, that's what we're doing here. Or do you mind if I use this one? You understand it's the same table? Is that okay? Yeah. All right, so I am not going to do this then for the sake of time. I think that'll be faster. So I'm following this table here because that's where we change the sign of the y values. So if I go right 1, down 1, if I go right 1, 2, 3, 4, down 1, 2, okay, then I'm going to connect the points, and there is the graph of this function. Now notice again, domain and range do get affected, but I'm not going to go over domain and range. So for x-intercept, we see the graph crossing the x-axis at this point. So that's where x is 1, 2, 3. So 3, 0. Okay, if you look at the graph, do you see the graph crossing the y-axis at all? No. So that means none. It doesn't cross the y-axis, so we say none because we don't see the graph crossing the y-axis. All right, number 7. There is a negative inside of the square root. So that means if a negative outside makes the graph reflect over the x-axis, the negative inside of the square root makes the graph reflect over the y-axis, right? So then reflect transformation is reflect over y, and the plus 1, up 1. So let's start with up 1. So let's go up 1 from the origin because there's nothing inside of the radical that tells us that we need to go left or right. So then for this one, I'm going to do the table for the parent function, x, y, 0, 1, 4, 0, 1, 2. Okay, now this affects the x value. So this is a horizontal transformation. So I'm going to extend this, and all I need to do is change the sign of the y of the x values. So then this still remains 0, this becomes -1, and this becomes -4. So then I'm crossing out this column. Don't forget again, these are directions, these are not coordinates. So if I go left 1 here, I'm going to go up 1. So left 1, up 1. If I go left 4, 1, 2, 3, 4, up 1, 2. And then connect the points, and this is the graph that is reflected across the y-axis, okay, with the given transformations. So again, let's see. So x-intercept for this one here, does it cross the x-axis? No, so that means none. There is no intersection of the x-axis. Y-intercept, is there one? Yeah, right there, where x is 0 and y is 1. 0, 1, and that happens to be also the origin of the graph. Okay, one more example. Let's continue to example number 8. Now notice, remember I said whatever is inside affects the x values. Now this is also counterintuitive. You think, oh, I multiplied the x values by 2, but instead you do the opposite, you divide by 2. Okay, so this was covered in lesson, I think, on quadratics and also absolute value. So what I'm going to say is it's going to have a horizontal, because it's inside of the radical, horizontal, so logically you think stretch. No, it's a shrink, okay? Horizontal shrink by 1/2 by the reciprocal of 2. So with this information, let me again do the table of values. So in this case, the x values are the ones that are going to get affected. X, y, 0, 1, 4, 0, 1, 2. Then take the x values and multiply them by 1/2, or take half of each one of those x values. Half of 0, still 0. Half of 1, 1/2. Half of 4, 2. Okay, then I'm crossing out that column. So then there is no plus or minus inside nor outside, so we're going from the origin. So from this point, if I go right 1/2, up 1. So up, right 1/2, up 1. If I go right 2, 1, 2, up 1, 2. So as you can see, this graph gets small because of that horizontal transformation. Okay, so it's being shrunk. X and y intercepts, well, they're both at the origin. So x-intercept is at 0, 0, and the y-intercept is no different. So the y-intercept is also at 0, 0. Okay, that's all for this one. The last example, we are asked to write a square root function matching the description. So they give us a transformations. We need to write the equation ourselves. So let's set this up. So this is the y equals part, and it says that it's being stretched vertically. So that happens outside of the radical by a factor of 6. So then we have 6 square root of, we don't know what goes inside yet, and this says, we know x is going to be in here. That's all we know for now. So translated 7 units down, that happens outside of the square root, so that means minus 7. And then it says reflected over the x-axis. So that means there's a negative in front of the 6. But if this said reflected over the y-axis, then the x will have a negative inside of it. Okay, so there is no left or right, so that means this is the equation for this problem. And we are done with this lesson.